So these slides are showing, they're showing types of agroforestry, if you like. I can't use the pointer because it switches the machine off, but the top is forest land, cropland, settlements, and grassland. All of them have got trees. So the point is trees outside the forest are very important. These 6 categories of land are the categories recognized by the UN Framework Convention for Climate Change for the reporting of greenhouse gas emissions. And post COP21, post the Paris meeting, it's quite exciting because more or less every country in the world now will have to report its land-based greenhouse gas emissions. Heretofore, this was something that only maybe 50-odd countries did, those countries that were signatories of the Kyoto Convention, and a lot of other countries like the US might have signed that, but they never actually ratified it. So we're going to have a great deal more interest in carbon on different types of land, and not just forest land, and on non-carbon emissions in those types of land. It just occurs to me, I'm going to be walking around a lot. Is that a problem for the recording? Yep, in fact, there seems to be no problem. So, crucially, though the government authorities, and in the case of Ireland, it's the EPA in Johnson's Castle, who do the reports of emissions from grassland and cropland, are going to have to consider the potential of any new trees planted on that land as well as what happens on forest land. And importantly too, we're going to have to get a lot more strict and going to have to understand a lot better a given parcel of land, is that forest or is it grassland or is it cropland? Heretofore it hasn't mattered too much, but that's something that's going to be important for farmers and for governments. So that's the background. I'm going to be talking about definitions of agroforestry, some of the research issues within agroforestry, and then a couple of policy topics at the end. One is how agroforestry is handled within the current CAP, and perhaps how it might be handled within the next CAP. And again, it's good to have Eugene around, because if there are any suggestions that you have about how farmers may be encouraged to better adopt agroforestry, then Eugene can actually channel those through into the considerations of new agricultural policy in the CAP post-2020. And then agroforestry and climate policy, which, as I said, is becoming, it's a very hot topic, and it's a particularly hot topic now because the LULUCF regulation is under debate within the European Parliament. There's about 5 committees of the European Parliament that are currently considering the regulation and what should be allowed and what shouldn't be within the emission cap that is allowed for countries to offset the sequestration of carbon within forests or within grassland or agricultural land against their emissions elsewhere. So how much should Ireland be? Ireland's in a particular situation at the moment in that it's unlikely to meet its greenhouse gas reduction targets. So the politicians in Brussels are discussing how much of an allocation from LULUCF should be allowed for each individual country to offset against their emissions in other parts of the emission sharing regulation, as it's called. So, first the boring bit, but what is agroforestry? It's actually surprisingly difficult to find a reliable definition because we have a whole variety of those. Many of the definitions include phrases like increased social, economic, and environmental benefits. Those are nice words, but they're not appropriate for a definition. A definition should be simple and measurable and quantifiable. We also have some definitions that talk about trees and others which include shrubs. The common element is mixing it with agriculture, either crops or animals. There is a nice simple definition which I like, which is the one which is embedded in European legislation, and is just agroforestry as a land use system in which trees are grown in combination with agriculture on the same land. And the definition of the maximum density of trees and the minimum density of trees is left to individual countries to define in their rural development programs. So that's an important agroforestry project at an EU level, which has its own definition. And I guess the question is, all these all these pictures are showing woody vegetation and animals grazing amongst them. So according to some definition, heather moor could be agroforestry because it's woody vegetation, managed woody vegetation. So could dwarf shrubs in Lapland, so could saltbrush, so could grazing of bamboo, so could isolated individual trees. So it's a bit of a movable feast, what agroforestry is, and I prefer not to worry too much about it, because frankly, it's hard enough to come to an agreement about what is agriculture and what is forestry. Agroforestry is somewhere between. Let's not get too hung up on the qualifications. But the crucial thing is there is a good definition of forest land. There's a definition which individual countries have to report to the UNFCCC Secretariat, and it's embedded within the European Union LULUCF regulation, and that's talking about in terms of 3 parameters. One is the crown cover, another one is the minimum area of a block, and the other one is the height, and that's the potential, the minimum potential height of the tree. Okay, so if you look at the Irish situation, which you share exactly with Latvia, it's the only other country that's got the same precise definition of forest as Ireland, the crown cover, the percentage crown cover must be 20% or above. The minimum area of the block must be 0.1 hectares, and the potential minimum height of the tree must be 5 meters. Interestingly, that's different to the UK, because the UK, presumably because of Scottish influence, says that the tree is anything that grows above 2 meters. So, okay, it's boring perhaps, but it's quite interesting for a farmer, because if a farmer's land is deemed to be, if he's got too many trees on it to be agriculture, it then becomes forest, he then loses his payments. It's also important for all the international reporting that happens. Those countries there, that is the FAO definition of a forest. So it's 10% crown cover, 0.5 of a hectare size, and 5 meters in height. The 4th column is looking at an optional definition that some countries use, and again, it's apparently used in Ireland, and that's the minimum width, which is, according to that, it's 20 meters. I don't know, Eugene, whether you would agree, but there is a document that says it can't be a forest unless it's more than 20 meters wide. I think we may have to have a debate about that. Okay, so that was Ireland. But interestingly, the characterization of whether the land is forest or agriculture is quite useful from the point of view of defining different types of agroforestry. So for example, if it's a forest, you have forest grazing, whereas outside the forest, it's more usefully called wood pasture. And there are orchard grazing, alley cropping, alley coppice, and so on. So different typologies for agroforestry. Okay, turning to research. Those are the areas I'm going to be looking at. Products and services management, soils, water and flooding, climate, carbon and energy, ecosystems, and then a little bit about economics. First point to make in terms of products and systems is that it is a very old system. Pliny the Elder wrote a treatise on how to manage trees and cereals together. So it's been going on for as long as that, and it was well understood. We have a lot of folk knowledge about how to pollard and how to coppice trees. Cricketbat willow, for example, in the UK is managed just as that, and it's the most valuable timber of any timbers which are grown in the UK. So it's not a new idea. There's a lot of historical knowledge to be gained. Of course, it largely fell out of fashion with mechanization. Examples of different types of agroforestry from the top left, where you have the Iberian pig grazing in evergreen oak, widely spaced evergreen oak. There's something like 7 million hectares of this Dehesa system, as it's called in Spain, or Montado system, as it would call in Portugal. Extremely beautiful areas, wonderful bird habitats and wildflowers. If you ever get a chance to have a holiday in the east of Spain, round about now or Easter time, go to Extremadura. It's next to Ireland, it's the most beautiful place in the world, I think. So other examples there of the silvo arable system from the centre of England, cattle, those are Aberdeen Angus, amongst cherry in Scotland, hens in orchards in the Netherlands, and this is an example from Loch Gall, just across the border in Northern Ireland. Quite a long-running experiment of widely spaced ash, different spacings and different management, but it's well worth having a look. And that's the longest established agroforestry trial within Ireland, the island of Ireland. So management options, obviously you have to consider means of protecting your trees. There's quite a lot of research work on that. You need to consider pruning. If you are growing agroforestry, it's vital not to be growing firewood, but to be trying to grow a high quality timber product, and you don't do that unless you prune. But even prune trees, as you can see there, have a significant animal welfare advantage. And even more so in dry, hot Mediterranean areas. So the other challenges are the clonal mixtures to be used, the opportunities that you have for fruit trees and for pollinating those fruit trees, choices about the orientation of the alleys. So in temperate regions, then a north-south orientation of the alley tends to be recommended because that gives a more even growth of the crop between the trees. In more tropical areas, then east-west might be better because shading is less of an issue. You may find that the width of the tree row later in the rotation can be expanded a bit because you're getting too much competition closer to the tree. So these are all variables that the farmers control. Another variable that is control is how to manage the competition between the roots of the tree and the roots of an arable crop in this case. Because what you want to do is ensure, can I do it? Not sure how to get up there, but how ensure that the roots of the trees are growing underneath the rooting zone of the crop. And there's some excellent experimental evidence from France again about how you can manage the crops that are used for the trees. So when you're first establishing the crops, you might do that within maize, for example, where there's a lot of side competition and the trees are forced to grow rapidly upwards. They don't produce so many branches. Then after 2 years, you would start to introduce your winter cereals, and the winter cereals are growing and establishing during winter, but so that they occupy the rooting zone before the roots of the trees start to grow. So the trees find there's not enough water left, and they are then forced to go downwards. And that's absolutely what you want, where you can share the full horizon of the soil and minimize the amount of competition. And that's what this experiment here is showing, where this is 0 going down to 4 meters. Somebody spent, as you can see, a lot of effort digging out the roots. So you can see in the forest spacing, traditional close spacing, almost all the tree roots are in the top 100 centimeters. Whereas in the agroforestry system, the walnut roots are growing down from about 150 to almost 300 centimeters. Another issue about timber quality. I always, for a long time, had in my head that if you grew any tree fast, as you would do with wide spacing if it's growing on good soil, then you'll get lousy timber. And that might be the case for conifers, where you're emphasizing, you're increasing the proportion of early wood versus late wood, but it certainly isn't the case for broadleaves. We could do with a lot more experimental evidence on this, but it appears to be the case, certainly if you look at ring porous species like ash, elm, cherry, black walnut, sweet chestnut, and a few other exotics, then your pores, your tracheids, are growing in what is effectively the early wood. And if your early wood ring is quite narrow, then that narrow ring is filled with pores. So it's a stress point for the timber. And the faster you grow, the more opportunity you've got for the tracheids to be better distributed within the timber, as these are showing. So as long as you've got good pruning to get rid of the knots and also to increase the cylindricity, minimize the fact that it's going to, unless you've got pruning, you're going to be growing a cone rather than a cylinder. So if you have good pruning, there should be nothing to stop you growing oak and cherry and elm rapidly sorry, did I say cherry? Oak and ash and elm. If Ian allows you to grow any ash, which is another point with Chalera on the go. That's the issue about spacing. The other obvious point is if you're growing trees at wide spacing, then each individual tree it's got a greater volume and it's got a greater diameter. So this is showing the ratio of, we're looking at cherry here. In the East Pyrenees, they're at about 900 meters altitude, and the agroforestry has a spacing of 100 trees per hectare. The forestry has 800 trees per hectare. And you're looking at the individual dyed volume of the tree. This is looking at the ratio. So the ratio of an individual agroforestry tree at year 6 is almost 4.5 bigger than its traditional forestry counterpart. That difference obviously declines as the plantation gets older, but you're still looking at a volume of twice as much in the agroforestry system. So if your final crop tree is only going to be 100 trees anyway per hectare, then why not let them grow wider? As long as you've got good pruning and as long as you've got an excellent initial planting stock, which is excellent genetic quality for your planting material, and that is often the problem. Particularly with cherry, a lot of the cherries that were given for timber have got too many genes of the fruit trees mixed in with them. So the theoretical concept of light capture is easy enough to grasp. You're looking at the red bars there for agriculture. You're looking at the total capture of light in a conventional crop monoculture over a 40-year period. So the crop is actually only capturing 20-odd% of the total input of radiation. In forestry on the right, you see that the trees on the top there initially are not capturing much, but as they get denser after 40 years, this is walnut in this case again, they're capturing up to about 50% of the radiation. In an agroforestry situation, you're putting those two together, so you're getting the crop capturing this amount, gradually declining, but still capturing that amount, and the trees capturing also that amount also. So your total radiation capture is greater, the capture of water and nutrients is greater, and your overall yield, the ratio of the yield for agroforestry compared to the monocultures, or the land equivalent ratio as it's sometimes called, can be 1.2, 1.3, sometimes 1.5 in terms of the net benefit that an agroforestry situation has. There are issues of the stability of the yield also. Clearly the yield, the raw yield in this case is dropping for the crop, but the variability of that yield is less. So this is the ratio of the yield in monoculture versus the yield in between poplar trees. And while it's dropping, you do find that there are years in which the agroforestry can outperform the monoculture. Just to emphasize again, in the French circumstances, the rapidity of some of the growth that you can see. So these are poplars planted in 1996 at the left. The next picture is 1997. This one is 2002. This one is 2005. 2003 on the left. 2009, 2010. So planted in 1996 and harvested in 2010. So that's what, 14 years, and you're getting timber of that size. And there are a lot of management options which are listed there, which the farmer can use to maximize the yield of his mixtures. I won't go into them. Okay, I should have perhaps shown these in white so you can read them, but I'll just read out on the left. These are the positive features that we've got good proof for, good observational proof for the benefits of agroforestry in terms of soil and nutrients. So there's evidence of a root safety net. The roots of the trees are growing underneath the crop, and they're quite efficient at absorbing the nitrate, for example, that would otherwise be leached through the soil. You have the capacity to design nitrogen fixing systems, either with a nitrogen fixing tree or a nitrogen fixing crop. There is quite good evidence of mycelia being shared between the roots of trees and the roots of crops. There's certainly good evidence that the soil structure is improved. The organic matter of the content of the soil is improved, and the evidence that the root exudates help to improve that structure. Leaf and root litter clearly benefits the crop, and there is a capacity for the forage to be fed to animals and for that manure to be used. Higher leaf land equivalent ratio. Hydraulic conductivity in those systems improves because the roots are creating channels through which the water can percolate. Erosion controlled, reduced leaching, sorption of ammonia I'll come on to later in the canopy. There's evidence of absorption of the soil in summer, therefore there is a greater area of pore space for the autumn rains to come into and be held rather than being turned into overland flow. There's quite a bit of evidence for hydraulic lift, which means that water sometimes is taken up from deeper areas, and the surface roots of the tree can exude some of that water in the early morning, which benefits the crops. Also, a lot of work about riparian buffer strips and water, and we'll come on to water breaks later. Uncertainty there about the effect of trees on nitrous oxide emissions. It's likely that trees are beneficial because nitrous oxide tends to respond to if you've got too much water-filled pore space, then you will have a lot of denitrification taking place and nitrous oxide being given off. The trees will keep the soils drier normally. Also, if you need to have actively growing roots through as much as the year as possible, and again, the trees will benefit from that. But we don't know that much about trees and nitrous oxide, nor do we know that much about trees and oxidation of methane. It's thought to be positive. But that leads us on to the next point, and that is that we do not need to think about agroforestry just in terms of rows of trees or widely spaced geometric designs of trees. Agroforestry is growing trees on farms. It's mixing trees with agriculture, and clearly there are a lot of tools available to us now to look at the soils, the humidity profiles of given farms or collections of farms, and to be able to better design where the trees should be planted within that network, within that landscape. So here you have the famous Pombren farmers from Wales who are actually lauded. They're mentioned in the Welsh Rural Development Programme as an example of how farmers should get together and plan how to establish trees. And they've been working together with Bangor University and the Centre for Ecology and Hydrology in Bangor to come up with landscape models of topography and of soils, and design together with the farmers the best place for those farmers to establish the trees. And it's a very good example of how participative research, if you like, can be done. And they've increased the total percentage of trees from 1.5 to 5, and what they discovered is that they're getting very much less flooding taking place. The porosity of the soil is increasing, and the flood in the rivers is much less pronounced than it was. The other potential advantage here is I was talking about the deeper rooting of agroforestry trees, or silvoarable trees at least. This is an example of a storm in Paris in France in I can't see the date there, but it was a particularly damaging flood which caused the storm, which caused destruction on the scale that you can see on the top right in conventional forestry. The two pictures on the upper part are showing damage to conventional forestry. That track, the upper track, went through this agroforestry area the previous winter, and as you can see, there's no damage whatsoever. So having deeper rooted trees is some significant benefit. Okay, that's wind. You may think also of the potential advantage of riparian trees for the control of floods. Again, the top right is the famous Roman bridge at Nîmes, and that's the the Gardon River in France, and below that, you can see these are rows of poplar, and these are big piles of detritus that were accumulated, filtered out, if you like, by the rows of poplars as the floodwater passed. And designs have been proposed of building water breaks of trees to intercept floodwater and to distribute floodwater. So instead of constructing large and expensive concrete gabions or barriers, just use your trees to build up natural swales and berms. And this is an example from Flanders, a very wet place as well, of farmers that are building mounds. And so the mounds are the berms and the swales are the ditches. And then they're planting the trees on the swales, sorry, the berms, and in this case also growing strawberries and things amongst the trees. Climate change, 3 levels of climate change I'm going to show you here. These are changes within the trees. So we're seeing evidence here during the daytime of reductions in temperature of up to 3 degrees under poplar 15 years, 30 meters height, and a concomitant increase in temperature at nighttime. It's obviously most pronounced in sunny days, and it's obviously highly pronounced in the poplar because it has a bigger canopy, but there's quite a lot of evidence of that. And if climate change does become an issue in the south of Europe in particular, then that reduction in daytime temperature is a significant advantage for agroforestry. Right, mesoclimate, next scale. We're talking about here the tens to hundreds of meters from the trees. So this is the windbreak type concept. So on the graph at the top, you will see that there will be a reduction close to the windbreak, but because your wind is being reduced further away from the trees, you will have a reduction in evaporation and good evidence, particularly in dry climates, of increased yields. Also complex weather patterns, which sometimes may cause eddies or vortexes within an agroforestry system and can be problems to be recognized. Okay, the other one is more interesting, well, is interesting, but not often talked about. And that's the effect of trees on the macroclimate. So here we're talking about tens to hundreds of kilometers from the trees. So you're talking about a landscape scale with trees in belts or individual trees scattered to increase the roughness and increase the evaporation. And what this work is doing is looking at the, again, I was brought up in a world which said that trees were bad because they evaporated water, and that then meant that the reservoirs didn't fill up with water and there was not enough water for local supplies. That's often not the case because evaporation goes into the atmosphere, and an awful lot of that evaporation is actually falling as rain further down the catchment. So if you're looking at big catchments, like these ones in Northern Europe or in the US, they're looking at whether the proportion of the rain that falls in a given area is actually falling for the first time in that area, or whether it's been evaporated by the vegetation and by the trees downwind and then falls again within the same catchment. So the overall message is it's very complex to model and it's very uncertain. But don't ever say that trees are bad because they intercept water and that is evaporated and therefore lost to the system. It probably falls again just a few hundreds of kilometers further downwind. And the other one is a very old study because I haven't been able to find anything more recent on that, and that's looking at the overall reduction in the average wind speed caused by a forested landscape compared to a bare landscape. And this is a transect taking place on the same day by this guy Jensen in Denmark way back in 1954, who showed that on this transect on an area basis, the wind speed was reduced by 50%. Whereas the upper one with a more open landscape on an area basis only produces 20% landscapes, wind speed reduction. Right, last few slides on how are we doing for time? This is a very interesting one too. So and there's a reference there to the work, but it's looking at the ability of foliage of trees to adsorb ammonia. And they've got experimental work and also modeling work looking at the effect of different types of tree barriers. But they're coming to the conclusion that the most effective way is actually to put the animals, the poultry or the pigs or the cattle underneath wide-spaced trees, and the canopy of the trees absorbs the ammonia. Now, ammonia is obviously something that is going to fall somewhere else. It'll be washed out within the rainfall. It'll go into watercourses. It will cause eutrophication. Maybe I was just hearing about the problems that we got with replanting deep peat and fertilizing deep peat and so on. I mean, you could look at it as the trees are actually filtering the nitrogen out of the system rather than causing problems. But that's something that certainly needs to be looked at. Okay, so ammonia is a pollutant, but pollutant of watercourses, but around about almost 2% of that ammonia will eventually turn itself into nitrous oxide. And nitrous oxide is a very damaging greenhouse gas, about almost 300% worse per unit weight than carbon dioxide. So any nitrous oxide you can take out of the system is an advantage. So that's that advantage. Very quickly, carbon sequestration picture is very different, very confused. There are many different types of agroforestry systems. There are many species. There are many spacings. It's hard to come up with a lesson. But looking at the literature, the recently published temperate zone literature, and looking at the total tons of carbon, in this case, not carbon dioxide, sequestered in those systems per year over various rotation lengths from 11 to 40 years, I think, 30 years there. We're getting figures of, in usually greater than 2 or 3, and sometimes as big as 12 or 13 tons of carbon per hectare per year. That's a very high figure for any carbon sequestration study, and shows the potential, which needs to be followed up. And it's early days yet with a lot of these studies, and it's so horribly difficult to get those results because a lot of it depends on measurements of rooting depth and rooting biomass, and that involves quite difficult studies. But the results are very optimistic. At the ecosystem scale, we clearly see that the tree rows themselves are a refuge for crop pests, but also for the predators of those pests. We see that the habitat is enriched along those tree rows, and on the bottom slide you can see, for example, for the biocontrol of the wheat aphid, that there are 3 species there of a hoverfly, a parasitoid wasp, and a ladybird, which are only there because of the vegetation which is in the tree row, in the vegetation row, and those predators of the aphid are able to provide biological control as opposed to chemical control. Last slide here on the economics before I come on to policy, just to show that this walnut plantation is 60 years old. Again, and it's in the middle of France, I think near to Bordeaux. It's 156 trees per hectare, and that's valued at 120,000 euros per hectare. So the profitability is pretty high if you're growing the right species. Point about the last one is that you see this is a model of poplar and wheat barley oil seed rotations with climate circumstances of Cranfield in the middle of England. So you're seeing the blue, you're seeing the financial cumulative net margin is clearly increasing in the blue for conventional arable. In forestry, what you're doing in the early years is growing grants, effectively. So the profitability in the early year comes from the grants, and then you're negative for a long time until your final harvest comes in. Assuming your final harvest there is 30 years. Agroforestry doesn't do as well as you might expect in that its cumulative net margin beats the arable for the early years until about year 8 or 9, and it then drops off. But it drops off because the calculations for the amount of light available are such that the decision was made that it's not profitable to keep growing arable crops. what clearly needed to be done in that model is that you reseed after your shading becomes too big. You reseed grass and you put animals in and include the profit from the animals. But the model doesn't yet do that. And also, sadly, a lot of farming systems don't allow us to do that because many farms have become so specialized these days that they're not mixed farms. They don't have animals available to be able to put in. Okay, quickly on to forest policy. I'll just remind you that there are 3 types of environmental policies within the EU. So there's the rules under cross-compliance, so the good agriculture and environmental conditions, which each European country has to fulfill. Those rules, GAIC 7 as it's called, applies to trees. Some of those rules may cause problems for agroforestry. For example, I think in Ireland, as in most of the UK countries, there's a stipulation that you're not allowed to prune trees until after the end of August. That's not the ideal time to be pruning a lot of trees. You should be pruning trees in July at least, certainly July, August. So it's a worry that constraint got in for the benefit of trees. If you're pruning trees as late as that, then you can potentially have disease problems with a lot of broadleaves. Next one is green direct payments. I'm going to show a horribly complex slide, but the only thing you need to remember about it is that it's not horribly complex. It shows how wonderful the CAP is because it allows a huge amount of subsidiarity to member states. So it's not complex, it's flexible. So those are the countries along the top. And those are the elements within greening, within Pillar 1, because greening, as you know, applies to farmers that have got more than 15 hectares of arable land. They have to use some of these greening measures. These are the countries that triggered which measure. So if we look at Ireland now, which is the IE, it's this one there. Sorry, I can't point. So Ireland has triggered, as greening measures, it's triggered hedges or woody strips, trees in line, trees in groups or copses, which is good. But it didn't trigger agroforestry. Agroforestry is in 13-odd plans for member states, but it's only those ones that have a double yes. It's a double whammy against agroforestry. It's not just any agroforestry that you get allowed to count for greening. It's only those areas of agroforestry that were previously included within a Pillar 2 agroforestry scheme. So it's the amount of the area involved is very, very small. But the point I want to make there is that a lot of these landscape features involve trees. And farmers can and should be encouraged to make more use of them as a greening measure, as opposed to just planting nitrogen-fixing crops, which is what 92% or whatever of all the greening money has been spent on that. Okay, so greening is still Pillar 1. Oops. Pillar 2 is the rural development programs. Those 35 regions out of the 118 regions within Europe implemented what's called Measure 8.2, which is the agroforestry measure, so money to plant new agroforestry. Ireland is not amongst those because forestry in Ireland doesn't come under the CAP. There's a separate regulation for forestry, but Ireland did implement an agroforestry regulation also. And we need to work now quite hard with those regions to share the expertise and to share the experience that they have in implementing this agroforestry scheme. What went wrong, what was good. So Northern Ireland, Scotland, and Wales are all implementing it. England was just about to implement it, and we all went to a meeting with the INDEFRA in England the day after the referendum, and rather than discussing how it was going to be implemented, it was abandoned because of Brexit, like everything else. Climate policy, very quickly, these slides will be available if anybody wants to look at them, but I like this slide. The guy on the right is the land sector negotiator who says gross net, net, reference levels, LULUCF, red, caps carbon equivalent forests and natural disturbances knows what LULUCF is all about. And then the negotiator at the left is saying wagga dagga dagga wagga dagga, because it's, if anything is complex in, if you think the CAP is bad, you should look at the LULUCF regulation. And the environmental groups at the right there are just saying that these carbon credits that you can get from forestry are just, we love these credits, now we can just hide our emissions behind the trees. So there's a lot of complaint about those, including in Ireland. Some of the NGO groups in Ireland see LULUCF as just an excuse by the Forest Service to hide their credits and get more of the horrible monocultures of trees established. So, one thing that doesn't make it any easier is that we've inherited political interference, if you like, with the way that scientists would like to do these things. So that's a farm, okay? All the emissions on the left-hand side, which are bounded by the blue line there, are this thing called LULUCF. So that's land use change and forestry. All the things on the right, which are the non-carbon emissions from the farm, are bounded by the red box, and that goes through a completely different route, which is called the emissions sharing decision, or now the emissions sharing regulation. So, and usually in each country, a different person, a different group does the calculations of what's involved. It's all agriculture, it's all land use, but the two are separate. And they're kept separate largely because the forestry groups lobbied very hard to keep forestry separate, because they didn't want to be lumped in with agriculture. They didn't want to be part of the common agricultural policy. They wanted to stay independent. And also because the NGO groups saw LULUCF, as I said before, just a means of disguising your horrible credits. So we've ended up with this political situation which makes no sense from a scientific point of view, and which most of the scientific organizations argued strongly against, but that's where we are. And as you can see, IPCC said that the integrated pillar, the AFOLU pillar as it's called, so the agriculture, forestry and other land use, said back as long ago as 2006 that should be adopted. But it hasn't been by the European Parliament. Here's just a few slides again to remind you of the difficulty that agriculture has in Europe. So those are effectively no net reductions in the non-CO2 emissions from agriculture. That's showing that LULUCF forest management is declining very rapidly. So although it potentially makes a big contribution to abating the emissions from the non-CO2 emissions from agriculture now, it becomes much less of an issue later on. So perhaps some of the arguments that we see from the NGOs are valid now, will become less so in the future. That's something I won't go into, but there are many complexities in the way that these calculations are done. That's explaining the difference between gross net accounting, doing gross net accounting with a cap, and net accounting. Okay, some of that is explained on the slide if you want to see it. But the overall message there is that it's much more complicated than it needs to be, and it would be much better if you looked at the net emissions in the base year, compared those with the net emissions in the year that you're looking at, and all land uses were compared using the same systems. Unfortunately, we've got ourselves into this position that forestry is calculated differently to everything else, and vested interests want to keep that way. We also have a lot of difficulties about something called the forest management reference level. So this is effectively the prediction that the Forest Service makes about what the emissions from forestry are going to be at a given time in the future. And then when they come to that time in the future, do the calculation and discover that the sequestration is bigger than they thought it was going to be, then those are the credits that they can count towards offsetting. But we have had a lot of debate about whether those predictions about what the sequestration were going to be were actually right. So we've had a history of showing the actual European recorded levels of carbon sequestration being significantly greater than what the countries said they were going to be. And there's a lot of carbon credits which are probably there by accident, by playing the system, by bad planning, by whatever reason, but there's a lot of carbon credit there that shouldn't be there. This very quickly is a message. I think I'm on my last five slides. This is quickly a message that things are going to get very exciting soon, because we have a commitment, as I said before, because of COP21, all the countries in the world are going to be doing reporting of land-based emissions. And Europe has been doing it longer than anybody else, and we've got better systems than anybody else. So the Commission is telling every member state that they have to move to the highest possible resolution. This is down here. This is approach 3. So each area of land will have to be geo-tracked. You'll know the size of the land and you'll know its map reference, and it will have an identity. And then at the left, you've got the methods which are used to calculate those emissions. And we're being told to move to tier 3, such as high resolution data of emissions. So every country is going to have to be moving to, well, 90% of countries will be moving to high-resolution modelling of emissions based on the best available soils information. And that's hard work for the countries, but it's potentially quite important for farmers. If the country makes the database available that they're doing this highly detailed modelling of emissions available to individual farmers in the same way as farmers currently have access to the land use information and their grants information, then we really can bridge the gap between emissions reporting at a national scale, which is done by countries for other countries, and emissions reporting where the farmer knows the contribution that he or she is making to that global national total. And maybe we can introduce incentives to help the farmer manage in a climate smart way, which will make a small difference for him, but added together for all sorts of farmers like them will make a big difference overall. So that's where I come in, and I finish with this thing called the Land Parcel Identification System, which I'm told Irish farmers call the ELPIS. And this is where they look to see their areas of land, what they're growing, and how much money they're going to get for each of those areas. So because it records the eligibility of each parcel for payments. And if you've got an area of rush, for example, then an inspector will come along and decide that you're not farming on that, therefore you only get 20% of your direct payment. But it's so detailed now with layers for reference parcels, agricultural parcels, ecological focus areas, so hedges, ditches, lines of trees, individual trees, that this is a fantastic resource to be able to use for land-based modelling, hopefully in conjunction with farmers. Last slide, I think, is showing the difficulty that occurs in similar circumstance in Spain. I was talking about the 8 or 9 million hectares of dehesa in Spain. So that's what it looks like. You've got scattered trees. Is that a forest or is it not a forest? So they're confronting that by using normalized difference vegetation index to look at the ratio of red to far red light to look at whether it's green vegetation or not. And they're looking at LiDAR to look at the, the amount of trees, the biomass of the tree effectively that is growing. And they produced a national open database where every farmer can go and look at every single parcel and sub-parcel and see what percentage of the base payment, what percentage of that is deemed to be agriculture. And a lot of countries throughout Europe are doing this. Fully open systems which are available for farmers anywhere and anybody anywhere to look at. You don't get the name of the farmer who owns each parcel, but you see everything else. Arguably, that's going to happen in more countries. Last slide is that's me. That's a guy called Stéphane Le Foll, who's the French Minister of Agriculture. And I put that up because he's been a great supporter of agroforestry in France, and the support of the Agriculture Department in France is one reason why it's the most successful country in Europe. And they currently have a target that 50% of farmers in France will be using agroforestry by 2025. And I wish we had something like that in the UK and indeed in Ireland. So that's it. There's various contact points there that you can find, and I would recommend there's an agroforestry conference in May 2008 in the Netherlands. So I recommend putting that in your diary too.